Okay, so for the next talk, I wanted to call up Russ White from LinkedIn. He's going to talk to us about BGP path validation.
Yep, thanks. Clicker's right there. Okay, clicker's right here. And so today, I am working under a double disadvantage. They put me behind a podium, and I walk when I speak. As my stepfather used to say, "Mommy, mommy, why am I running around in circles? Shut up or I'll nail your other foot to the floor." And they won't let me draw on the slides, and I have to talk with my hands. So if I wave my hands randomly, just ignore it, okay? So that's okay. So today, I'm Russ White. I'm with LinkedIn. You may remember me from other places and other times, but right now I'm at LinkedIn on the architecture team, doing cool stuff with data center and BGP security. Going to LinkedIn has convinced me of, or has impressed upon me, the importance of path validation and BGP security. We're an open peering company, and path validation and BGP security are a big deal to us. So I want to walk along and just talk a little bit about where we are, where I think we are. And I'm going to give you some ideas about what I'm working on right now, or what I have a small group of people working on right now. But I want to impress on you one thing from this talk, is that whether or not we have a viable solution, we need one, because this is a big deal, and it's coming our way like a freight train. I have some inside contacts at DHS and other places, and I've been told that there is no government mandate right now from the US government to do something about BGP security, but there probably will be in some period of forthcoming time. And whatever system happens to be on the block when that mandate comes will be the system that will be mandated. So if you don't like what's on the block, or if you think it's not deployable, or it's not deployable in your network, then the time to speak up and do something about it, or to try to help design something that you find deployable or whatever, is in the now rather than in the 5 years when the mandate hits, or whatever the time frame is. I don't want to give a specific time frame. I'm just making things up. Okay, so I did that a lot, by the way. All right, so we already have origin authentication, and I really don't have to spend a lot of time on these slides, right? Because you already know this. We have the RPKI, and I'm not here to tell you that we should either use or not use the RPKI. That's actually a decision that LinkedIn is going through right now, is trying to figure out what we do with the RPKI stuff. So that's okay. But we all know how this works, right? We have AS 65002 is authorized to advertise some /64, DB801/64. You should be proud of me that I'm using v6 addresses, right? I have converted all of my writing and all of my other stuff to v6 addresses. Anyway, 65,000, and those are actually the right ones too. You know, I didn't use just some public space. Those are actually the documentation addresses. So 65,002 creates a resource certificate signed with a private key and additional parameters. This is placed in an RPKI database, which is today distributed through rsync. And then when you actually look at, hello, maybe not, Tony. I think I actually went one slide too far, didn't I? That's okay. So now when AS 65000 receives this route for DB801/64, it can use the public key from the RPKI, and it can validate the ROA, which is countersigned by the IRR, or the NIC, or whatever you want to go into for language there, and it can check the origin authentication. This is really cool. This is useful. It gives me origin authentication. I'm, again, not going to discuss what the deployment state of this is. I think Aaron just came on board, which is probably a good thing, and we're looking at what we're going to do with this. Now, this is kind of cool, but there are lots of attacks that still can happen with origin authentication only. For instance, I can, AS65003, who wants to consume the traffic for DB801/64, can advertise the, oh, I used an IPv4 address in the slide. And it's the wrong address. That really stinks. Anyway, I didn't catch them all. So, can advertise DB801/64. You just have to pretend that's a v6 address. With a one behind, it can say, I am attached to AS65002, and I have a connection to them, so therefore I'm going to advertise this route with 65002, 65003 in the AS path, and 65,000 will be none the wiser. So to get around this type of attack, we need some sort of path validation. So the first thing I want to do is I want to talk a little about requirements. I've had a lot of people ask me about path validation in the last 6 months or so, and again, like I said, when I onboarded with LinkedIn, the first thing they impressed on me was that path validation is a big deal for us. And there are various reasons that I could get into, but I won't. But anyway, so some of the requirements that I've talked to people about, and you can agree or disagree, and I'm happy if you disagree. In fact, I'm really happy if you disagree or agree. I don't really care. I just want your input. Right or wrong, good or bad, I just want your input on this. This is what I've heard and brought up or come up with. Reuse BGP because it's trusted and understood. This does not, however, mean reusing the current BGP peering sessions. We'll talk about that in a second. Using a new address family or a new message. Right now we're looking at a new address family in the little group of people we have gathered together, but that's not a given. That could be changed at any moment. No reason to reuse current best path for this application. We want to reuse existing policy mechanisms if possible. This is one of the beauties of running BGP, is that you can attach communities to your advertisements, and if you have a community that you use to filter routes, you can use that same community to filter advertisements for path validation, so it's kind of cool. Don't mess with origin authentication in general. Again, I don't want to argue about origin authentication and whether what we have is good or bad or whatever. That's not really, it seems to be deploying. I'm happy if it deploys. It's not perfect. Nothing is perfect. Everything is a trade-off in the world of complexity and network engineering. So it is what it is. And so the one thing we would like to think about is rsync seems to be a scaling issue that I've heard a lot. I've heard this through the grapevine and from people. And I'm not sure it's absolutely true, but I've heard this, and I think that it might be possible or it might be useful to think about a way to allow whatever we do for path validation to replace rsync in the long term. My big thing is I want to solve 80% of the problem space in a deployable way. I want it to be, so one thing is that I have come to the conclusion after looking at this problem for 15 years that there are no perfect solutions. And hence, if I can solve 80% of the problem in a way that costs me very, very little and I can deploy it, then I can find other ways to solve the other 20% of the problem, and I'm perfectly happy with that solution. I think Kata was on stage last. I think they might have some ideas. Since they're talking about internet measurement, I think there may be some ways to measure things and look at things that you can catch the 20% that straight up path validation can't do. So, again, an example I put on here is stateful inspection IDS pairs. There are various things that I do in the networking world where I take pairs of solutions or multiple solutions and try to figure out what to do. There's a thing on here, don't make the edge do crypto. I'm not convinced that's correct yet. Persistence in face of DDoS, I actually am not convinced that's correct either, but it would be a nice thing to do. All right, so rethinking requirements. One thing I want to make sure I do is I want to hide things that aren't otherwise available. This is a big deal for a lot of transit providers. It's not so much for me necessarily, but it is for a lot of people. Being able to hide things that are otherwise not available, or otherwise that you can't take the route reflector or a chart of the internet connectivity and discover things. I want to be able to hide things that you could hide in other ways. I want to be able to control where information is advertised. I want to be able to tell my peer what my interconnections are without them being able to tell their peers, if I can do that, if there's a way to do that. And now remember that this is a trust mechanism, and clearly people can play against the rules or play outside the rules and do whatever they want to do. I want to be able to optionally attach peering types and other policy to specific relationships. This is optional, and I'm very insistent on this being optional at this point, because I understand, again, that some people don't want you to know what their policies are. Now, I will say later on that the more you expose your policies, the more secure things become. But there are business relationships, and you just have to be, whatever that is, it is. Now, another thing that I am thinking about in requirements, or that we have come up with in this little group I'm working with, is that we want an overlay carrying new information. It has been very insisted upon me, or very impressed on me by various people, that I do not want to touch existing eBGP peers. So even if I'm using BGP as a transport because it's convenient and it's neat and all your NOCs already know how to configure it, I don't want to touch my existing eBGP peers. By the way, this is for me as well, okay? LinkedIn doesn't want to touch my existing BGP peers. It's very important from a scaling perspective and various other reasons. Incremental value or incremental deployment should add value incrementally. This is a very big deal. And so this is the concept that we're working with. Some of you might find this slightly familiar. We've gone back to the drawing board and rethought some things about what we're doing. But conceptually, we are working with AS level semantics. I say we have a very small team formed of a couple of different providers and a couple of different vendors that we're working with to come up with this. This is not anything that's kind of big public stuff right now. We're just batting ideas around on a little mailing list to try to figure out what we're doing. Only AS level changes should be reflected in the base advertisements. This is a scaling issue. As much as we can, more detail may be included, but doesn't have to be. So conceptually, you build a set of path pairs. Each path pair can contain a policy if you want to. These can be used as a set of path AS filters at the AS edge. Depends. So one of the things that we've argued about and discussed is, frankly, I don't care what you do in your AS. All I care about is getting you the information to decide how to do path validation the best that I can. And how you use that information is completely up to you. So if you want to use that as path filters, or if you want to use that as some other whatever you might want to do, it's not really my business to delve around in your AS, so you do what you'd like to do. I'm just trying to find ways to provide you with the information to make this work. So for instance, if an advertisement is received with the AS path 65,004, 65,003 at AS 65,000, you can look and say, is AS 65,004 connected to 65,003? Yes. Is there a policy along the path that says I shouldn't be receiving this route? No. That's only if the policy is exposed. Am I connected to AS 65,000? Yes. I have an 80% reliability, I think, thereabouts, that this is a good route. Now, again, doesn't solve everything, but network engineering is a set of trade-offs, and it is what it is, and I'm hoping that we can find other ways to solve the rest of the problems later without getting too much more intrusive than where we already are. Uh-oh. Uh-oh. Don't touch the bad button. Ha! Hey! Ah! Okay. Anyway, so conceptually, this is a tree-based DAG. I assume you know what a DAG is. It's like an SPF or a Dijkstra SPF without taking anything off. Policy can hang off the node, so we have another name for this called a PassState Vector. You may find a research paper out there on that that's very old. So I'm really not going to spend time talking about this. If you really want to talk about this, feel free to send me an email, catch me afterwards. I don't really care. I don't care about this. This is some stuff about packet formatting that we were talking about. Yes, Randy's shaking his head. Okay, Randy wants me to go back. I'll go back, and I'll talk about this. This is conceptually one way of doing this. We actually don't know how to do this, okay? That's why I was going to skip this slide. Yeah, that's fine. This is conceptually. We have been talking about within our little quiet little group talking about this, that you could use BGP AF and you would reformat the AF and do special best path because this is the easy thing to do. Okay, so I'll be honest, I'm not a big fan of overloading BGP with everything in the stinking world. And if I'm going to overload BGP with everything in the world, I'd really kind of prefer to do it in a new message type rather than a new AF. But the world is what the world is. And tilting at windmills is not my favorite hobby. So I'm not going to argue about what the formatting looks like. Operationally, AS 65,000, the way we're thinking about doing this is that you could advertise 3 different connectivity sets. For instance, you could bound a community using communities, an AS set, or a set of connectivity, which would be signed with your private key, which could be validated by your public key. And I'm not going to get too deep into the crypto because the crypto is the crypto. And, we have some smarter people about crypto than I am. in the world, and we're kind of relying on them and other people in the community to help us with this. But anyway, community bound. So again, I'm thinking in terms of if I can attach a community to a route, I can attach it to this advertisement. This is one of the joys of using BGP, is if I have the community sets, I can actually filter with the same communities on my edges. And where I'm filtering routes, I can actually filter connectivity as well. So this is just a general idea, again, not validated or borne out. Operationally, again, I can use transit communities to block routes one hop away from me if I want to. People can do bad things with your information if you hand it to them. I'm sorry, I can't do anything about that, but that's the way it is, right? So I can actually mark non-transits in the peering relationship. We're talking about adding bits for this that would be encrypted and validated in a way that would allow you to declare a customer, as a valley, and block the valley routes in the network. Attacks resolved. Of course, if 65,005 advertises DB801 with a path of 65,001, 65,005, then you can actually look at your graph, or you can actually look at your, I won't call it a graph, but however it's actually implemented in a particular instance of this type of thing, you can actually look at the pairs and say, you know what, 65,001 doesn't have a connection to 65,005. And by the way, even if 65,005 advertises a connection to 65,001, if you know much about Dijkstra and SPF, you always run a two-way connectivity check. So if 65,001 is not advertising a backlink back to 65,005, then you know the connection doesn't exist. It doesn't matter what 65,005 claims. It just works that way in that type of a thing. Now, if someone decides to expose who is not supposed to be a valley, then you can always mark that information and block valley transit through a valley. For instance, 65,001 in this instance should not be a transit path between 65,002 and 65,005. So, you know, you can actually mark that and make that not happen. So thoughts on the solution? I think this would meet the objectives of reasonably worded government mandate. Now, I said reasonably worded, so it's reasonably worded and government in the same sentence might seem like an oxymoron to some people, but that is what it is. I think it would protect about 80% or more of what needs to be protected. Works with existing origin validation if we want it to stop hijacking, stops truly out of the path man in the middle, is not culpable to replay attacks necessarily. It's all kind of dependent on what you do with your certificates, but that would actually do. Can protect your private information in a way that you want to. All right, the path forward. We have a small group working on this. We are slowly but surely increasing the group. We need some community support to think about this a little bit. We need more thinkers thinking about this. We have not taken this to the IETF yet. We are trying to get actually to the point where we have implementations before we take it to the IETF, just to be realistic about things. If a mandate's forthcoming, the goal is that, we really want to have a solution on the table if something happens, if somebody says this must take place. And I understand, because I've talked to a lot of my friends in the provider community, that lots of people want to do a lot of different things that are a lot simpler. For instance, let's let every tier 1 set up their own IRR and we'll just solve the problem that way. Okay, so I live on the edge and I'm not really happy with that solution for various reasons. And I don't think tier 1s and tier 2s should actually be happy with that solution either. Some people are saying, let's go back to the IRRs. There's been a lot of studies on the IRs, and I think they're probably reasonably correct in a lot of cases from what I've heard. Randy's shaking his head no, so I know I'm going to get called on that one. But nonetheless, I think that the problem with the IRR system is that it's easy enough to convince people to put information in, and it's hard to get people to take the stuff out once it's invalid. So I think we need something that's a little more dynamic and works as the topology goes and can be automated and DevOps. Ooh, you like that? I use that term. I'll say it 3 times. DevOps, DevOps, DevOps. All right. Anyway, can be coded up and DevOps. And I think we need a lot of this stuff going on to make this better. So questions, and I'm going to give you my email address even though it's not in here. I'm really difficult to find. It's russ@linkedin.com. I don't know if you can remember that or not. but that's my work address, is russ@linkedin.com. And Randy's standing at the mic, and so is Sandy. So I'm going to duck underneath the protective cover
Not at all. Not at all.
of this podium. So there are bad things about being behind a podium. There are good things about being behind a podium. Yes, Randy.
Randy Bush, IIJ. DevOps is the operators finally discovering that those computers are programmable.
Yeah, there you go.
It's really nice to see your thinking matured over the years. Really cheering. You should be aware that rsync is already being replaced. There's internet draft for it, and there's implementations and testing. The one fundamental thing that bothers me about inter-AS map being the essential semantic is that inter-AS routing is prefix specific, not AS specific.
Yep, I understand that, sure.
But otherwise, keep hacking, man.
Okay, good, thanks. Now Sandy's going to beat me up.
I'm not big enough. I think you'd win the fight. Could you go back to, I don't know, it was the slide where you said, here's how origin validation works, and you all understand that?
Oh, no, don't pick on me about origin validation.
It's way, way, way back. Way, way back.
Way, way back.
Way back.
Which one do you want to see?
This one. Okay, AS65002 creates a RO, there's a ROA signed with a private key, right. Okay. This doesn't have any bearing on your subsequent discussion.
No.
But I did want you to understand if LinkedIn is looking at this, it is most emphatically not the AS that signs the ROA saying who's allowed to announce it.
Right.
The prefix holder who has a right to use the address space. So, you know, if you're going to use this slide again.
This is a very loose set of slides, just to give a general overview, Sandy. Don't ask me for precision in 2 slides.
Well, you know, say 2001 creates a ROA signed with a private key. You know,
yeah, that's fine.
Just to, well, in the IRR world, for most things in the IRRs, it's the AS that's that has the authority to say things because it's their routing policy, except for route objects. And it's typical to see people carry that forward to the ROA world. Yeah. I just, okay. Randy already mentioned rsync. There's a new draft in the CIDR working group called the RRDP. We kind of call it the Delta Protocol, and RIPE is implementing and testing.
Okay, good.
And Randy said, you know, it's prefix specific. The R&E track yesterday had a talk by someone who did some measurements of the Valley Free Gal-Rexford model and the AS paths that exist, and 65% match that model, but that means 35% don't match that model. So, you know, that you got to keep that in mind. And there is work in the GROW working group to add a bit to the BGP updates to say kind of whether it's up or down, sort of. So you should know about that. And the BGP Set protocol could then be used to protect those bits, and you'd end up with a cryptographically assured discussion of what the policy was on a link.
Right. So yeah, so I intentionally did not mention BGP Set because I didn't want to come here and like beat up on anything. That was my intent was just to.
Well, you've got an in-band mechanism using cryptography, so that's another in-band mechanism that uses cryptography.
Exactly. So yeah. Okay. Thanks, Sandy.
Okay.
Oh, it's fine. Oh, there's Doug. Now I'm going to get beat up again. I know. Go ahead, Doug.
Not at all. From what I could see, what you're proposing, or at least outlining, bears some resemblance to SOBGP, which had full specs that we could read. Can you characterize like where your thoughts differ from the previous SOBGP?
Yeah, so in many places, first of all, we have abandoned origin authentication within path validation. We've separated those two entirely. And second of all, I think there is a completely different group working on this that is much more realistic about what we can do within BGP itself and how to manage things in BGP itself. And I think the third thing is you know, we're trying to avoid dabbling inside the AS. We just want to try to provide people with the right information to build their own tools and do what they want to do. So I think there's a lot of differences in those areas. It's much more, and beyond all that, I think I actually have 2 implementations perhaps on the verge of being committed. So I'm a little bit happy about that.
Many of your slides said you had no idea of how to.
Yes. So these are
Is
kind
this
of
non-deterministic
well, this is kind
code
of
that's
this is
being
kind of
committed?
experimental, right? This is kind of, will this actually work? Can we do what we want to do? I'm not going to lay down packet formats right now because I don't actually. I think part of it is that we need to get implementations under our belt to understand if the packet formats anybody is thinking about will actually work. So that's a crucial key. A little more experience with what we're doing. Yes.
Hi, Ross, Rüdiger Volk, Deutsche Telekom. Well, okay, I would be interested to have a clear description of what information model you want to use. You are coming in, and in the presentation in particular, saying, well, okay, rsync is a bad transport, which, well, okay, other people are working on. And then, well, okay, BGP is a nice transport, and then you come up with stuff that is to a large degree structure following the chosen transport. And that's kind of not
Yes.
really the way I would like to look at, well, okay, expressing
Yes.
policy in a more abstract way. The next thing is, well, okay, for getting things actually secured, which I think we want to, and which quite certainly would be part of a mandate, if the mandate is reasonable. Well, okay, I'm not hearing the security design, which should take care of making sure that actually authoritative data is put into the system, and the integrity of that data and the authenticity of the data is secured, and trusting that, well, okay, after we force some fuzzy data model into an existing transport to fix that later on, does not look like a very promising and reasonable approach.
Okay. So first of all, on the data model, contact me off after, or email me or something, because we can talk about that. That's not here in the slides. There is thinking around it, but it is not anything definite. As far as making sure that the data is correct, so I will tell you that we are on, shall I say, very touchy ground with this part of the problem, because I have talked to certain providers who have said, I do not want any outside body playing in my space and trying to authenticate who I'm connected to or not. On the other hand, from a security perspective, it's very important to make sure that that information is correct. So there is a fine line here someplace, and at some point we're going to have to figure out how to make this work in a way. Either it's going to have to come down to we have to do this anyway, or we're going to have to come down to the point where we say, we're going to have to find some way to make all of this work together. And I don't know the answer to that question. So that's why it's not in the slides.
Well, I think there cannot be a question about that integrity and authenticity of the data that is exchanged inter-domain has to be secured.
Right.
And
I agree.
I do not see any concern that actually would say, well, okay, we have to bypass that.
Yeah, okay. Well, we can talk about that after. I have people who have told me otherwise. Anything else? Great. Thanks.